Hello guys, a very warm welcome to my IT class. In this video I will be discussing linked list data structure. So basically what is a linked list data structure, to what class it belongs, and how we can create linked list dynamically. That is what the agenda of our today's session. So let's first see how a linked list appears. Then you will get an idea how we can create it. So you can see it is, as the name tells, linked list. The nodes are linked to each other here. So these are called as nodes. This is a node. What is a node actually? That I'll explain you. Just give me some time. So this node, these nodes are connected to each other through the links. That's why the name is linked list. So linked list, it's a linear data structure. So what is the meaning of linear? When you start traversing the list, you will find only one path ahead. There will be no path, like distraction will not be there. There will be no diversion. There you will not find two paths. There is only one path. So this way, you will be moving in a linear fashion. So data is stored here in linear fashion. That's why the name is linear linked list. Now, how actually it stores data? We can have actually two ways of representation. One is a sequential representation of a linked list. Sequential. When we say sequential, we use a 2D array to represent a list. Say this way, we have a 2D array, and here this represents a data, and where the next data item is available, that will be through this link we use. So that time when we use a sequential, the link will be a simply index, that is a index or subscript integer. But when you make use of dynamic allocation, non-sequential, that time what happens, the nodes are scattered in memory, they are not in contiguous. You know, array, it is a contiguous. So when you represent a linked list with array, it is a contiguous, or sequential, it is a contiguous. Non-sequential, when you make use of dynamic allocation, so the memory will be randomly we are getting, and there we establish link with the help of addresses. So these are called addresses. Say this is a node, it is having some address. It is a node, some having address. The address of this node, the address of next node is given or stored in the previous node. So again, in this node, the address of next node, this is 3000 is the address. So these addresses I have taken, they are arbitrary addresses, they are not actual. When you run a program, that time you will get different addresses. Just for explanation, I have considered these addresses. They will not be always 1000, 2000. They are hexadecimal numbers. So even if you convert it to unsigned integer, they will be coming like 6536. This sort of address it will be. I'll show you how it will be there in memory now, how it is represented in memory. Such a list we'll see. So this way, when you create a first node, you are creating one by one as and when there is a need. So on demand it will be there, on demand. So whenever you want a node, you will create a node. You will allocate memory at runtime. For that, you will allocate memory at runtime using new operator in C++. Say you have allocated, you have demanded a node, the system will return you that block or chunk for the storage of node. So normally the node has two parts, one is a data part and the other is a link part. So here your data will be stored, say 5, and here the link will be stored. If this is the first node, that time there is no address, it stores null. So when the second node comes, when you request for the second node, again wherever the memory is available, it returns a chunk or block of that memory, and there you will be storing again a data, and some data, say 8, and here this is the latest node you have, that's why you will store. But before this you have already a node, so this address must go to that node. So here 2000 will come. This is how you establish a link between this. Again, say you have requested another node, the system will return some memory, and there you will be again storing data, say 9, and this is not now the last node, this is the new node is going to become last node, that's why it stores the address null, and this previous node must store this new node's address as a link, say 3000 will be stored as a link, and this is how you will establish a link between this. And same way, say you have created again, say 4000 will be the new node. This is how in memory they are scattered, they are not in contiguous. So when you make use of dynamic allocation, dynamic allocation, why we need, you already have discussed, will not be wasting, will not fall short of memory, that's why we should prefer dynamic memory allocation scheme. So that's why I am creating a linked list using dynamic concept. So here when you use a dynamically allocated memory, and when you request to the system memory, it will not give contiguous blocks, the memory blocks provided will be scattered, so you need to establish link, and this is how what happens here, you will get a scattered things, the nodes are scattered in memory, and there is a thread between them which will link, that is the link. This is how it is there. Now let's see in detail a little bit more about the node. Now say how we can represent a node in programming. You have already seen that a node is basically what it is, it's a piece of information which has a data part and this is a link part. The data could be anything, the data could be, say you are creating a list for customer, that time the data part could be ID, a name, address. This way this entire thing represents data, and link will be simply an address, or you can say it is a pointer to the next node, we say. So now here how we should represent such a node in program. Now to represent this we take the help of structure feature of a language, say C++ provides a structure concept, so we represent a node using structure. So we'll define struct node. So this node represents data. So right now we'll go for only one integer variable here as a data. You can have multiple data items, but for understanding the list, first we'll have one data like integer data, and then we have to have a link. Now we need to decide the type of link, because whenever we declare a variable we must decide, or we must declare it. So now we should declare link. What should be the type of link? Link, already I have said, it is an address of another node. That's why when it is address, it has to be a pointer like this. Okay, what kind of address? Should it be integer? No, it should not be integer, because what you are storing here, you can see you are storing address of another node. In the link part, this is a link. So what you are storing here, it is 2000. So 2000 is what? It's the address of another node. So address of the node of the same kind. That's why we need to take the help of self-referential structures we call. So it will be of the same type node, because this I have defined now node as a data type, ADT it is user defined data type. So because the link is representing address of the similar node, that's why we need to represent a link of the same type here. Such structures we call it as self-referential structures. So now linked list uses such a one structure now. So we have to define such node, and then we can create a list. Now let us see. In this video I'll be discussing how we can create a list and how we'll display. These two things we'll see. For this we'll write a main, because we are using the object oriented approach, so we'll be defining classes here. Now if you define a class, for that say how the main would look like. First we'll define main, and as per that we'll define functions. Say I need to represent a ADT, abstract data type, like list. List is an abstract data type. Now it is a class, so I'll say lst. So now what you call this as, this is an object. Now in object oriented programming or C++, a variable of class is object, instance of a class is object. So lst is an instance now, object. So now lst represents one complete linked list. lst represents one complete list. So this is one object now, one object. Now you have just created it, okay. Just you have created the variable object, but you need to actually create the list now. So I'll be defining a member function called create list, or just create you can say, and that will create a list for some nodes. You can give number of nodes in the function itself. Number of nodes you can specify there. We'll see. Though this is how I'll be calling. Create is a member function defined in the public section of the list class. And then once you create, just see how it is there. List, display the list. These two functions we'll discuss in this video and we'll conclude it. Let's now see how we'll define class now. You have seen now what is the main function. It will create one object for list representing list, and on that object we invoke create member function, which will create the list, add number of nodes, and then same list we can display. So these two things we are defining in a class. Now let's define a class. Say class list, but we need to use a node for this. So the class list uses node. So before the list, what do you do now? Define a node, struct node, that already we have defined. Same way, let's take a integer data, int data, and then the link will be a pointer. It is address, that's why it is a pointer, and it is of the same type, that's why the node will be there here. Okay, this is what your structure is there. Now we'll go for defining list. You have seen here now in the first typical list. So this is the typical list we have seen. So here it is something you are finding. What is this? What is this? This is a head. So every linked list is identified. Usually when we talk about a singly linked list, there are different types of linked lists: singly linked list, doubly linked list, and circular, non-circular. So it is not a circular, it is non-circular. So in the non-circular linked lists, we have head. How we identify a list? Using its head. In circular list, how we identify a list? Using the address of last node. In non-circular, we have address of the very first node, and that we call it as a head. And what is a head? Head is not a node. Remember, head is not a node. Head is just a pointer which will hold address. Say such a pointer. What is this? Link is a pointer, no? That way head is a one pointer which will store address of the very first node. So we need to create, so we need to identify the list through head. That's why your class must have head. Your class must have head. So that's why we need to create the main data member will be here head. Say I'll take head. Okay. But what should be the type of head? Since head is an address, it is a pointer. And what kind of address it is? It is representing address of a node. Hence it should be node. Hence it should be node star, like this. This is a private by default. Now let's have member functions in the public section. One is a member function which will create the list. So void create list, we have already called it in main, you have seen. So this is what the create. I'll not be going to define here, I'll define it outside. And then void display. This is also going to display the list. So when you don't have any list with you, so there is no list now, what should be the value of head that time? There is no list, nothing is there. So when there is no list, head will be initialized to null. So head is your data member, head is a pointer. You know, when we want to initialize in instance variables of a class or data members of a class, we make use of constructor. So we use a default constructor here, list. So this is a default constructor where I'll initialize head is equal to null. head will be null. So whenever I create a object, automatically the constructor will be called and it will represent the list, empty list. So when you create, actually the pointer will be there. How it will do that, we'll see here now. So we'll define now create, void create function we'll define. So let's take this one, define create. Just a moment, I am opening a page. Now here we have two ways of creating a list. Say, what are the two ways? We need to understand those two ways. One way I will represent right now, and one way I will try here. So one is what? Now see, notice how I create a list now. Notice just. So how I am creating? I am creating a list by adding nodes at the front. So create a list. First one is what? Create list by adding nodes at front. Second way is opposite. Create list by appending nodes at rear end. This end we call it as a rear end. Appending means at the end you will be doing. So this we will see in the next video. Today we will see how we can create a list by adding a node at the front. That I will show you. We will define a function for it. So what is it? We have already said the create function is there, void. Since it is a function of list and we are defining it outside, making non-inline, list create, this is how it is there. It's a member. So take one variable like int n for number of nodes and take one node pointer for new node, nn, say new node it is. If there is a need, we'll again come back and we'll see. So ask the user how many nodes you have. So cout, enter number of nodes, how many nodes you want in the list, number of nodes it is. So it will be seen n. Then after inputting n, you are supposed to add those many nodes. So you run a loop for i0, I less than n, I plus plus. What you need to do? You need to create a new node. So nn is equal to new node. You are creating a new node and append the new node. Add the data to it. Say cout, enter data, then input that scene. What is that? Nn data. So you know, whenever we have a pointer in a hand, how we access? We access with the help of arrow operator. Because nn is a node pointer, we have a arrow operator for that. If we are just simply a structure variable, we use dot. So nn data. Now nn link we are supposed to modify. How you will modify nn link? This is your very first node. So when you create the very first node, the link has to be, because there is no further node, the link has to be null. What I do now here, nn link will be head. What head I have? Head is accessible to me. Head is a data member because I am in class. Create is a member, so head is accessible. Head I have already initialized. For the first time, head will be null. This is how nn link will get initialized to head. And your new head now. New head will be what? New head will be the new node. That what you had earlier null, now that will be replaced by address of this new node. And you will go to the next node again. So this is how that's what I guess. We'll have a dry run and again we'll check it if anything is there. Let's have a dry run of this one. Say now you are creating, you have said you have given the number of node as say 4 you have given. When you give the number of node as a 4, first time when you come for i0, 0 less than 4, you will create a new node. Say this is a new node you have created and let's say the address is 1000 and you have updated here C in NN data, say 5, and NN link, what you said, head is initially null, so you got it like this. Then what you made, you have already head with you. The pointer class has a variable like head, so in that head you are storing the address of new node, say 1000 you stored. So I'll take a new page and there I'll show you, it will be more clear. So what we did now, we have already a pointer like head with us, and we have created one new node NN, and the link we have made null, and the data is say 5 I have given. Say its address is 1000 and you have given this 1000 over here. Now again what happens now, I will be now, because you are in loop, so you will go back here now with the new value of I is 1 less than 4, true. Again you will enter, again a new node will be created, again a new node will be created. So let's create a new node again. A new node is created, NN, let's say its address is 2000, and what we are doing now, NN data, say you have given some data as 8, then how you are updating, NN link will be head. What is the present head now? We have present head is 1000, that will come here now, and this is how the link is established. This is how the link is established. And then what we made, the new head will be, just a moment, the new head will be, so you can see now the new head will be NN, that's why we have to change it now. The new head will be NN is 2000 here, and the new head will be 2000, and again I will be now 2 is less than 4, again a new node is created, say this one, its address is 3000, so NN link will be head, present head is how much, 2000. So this is how I established the link here, and then the new NN, that is NN 3000, that will become your head. This is how it will be that. So this way you will be adding a list here. Finally you added 4 nodes, say this is 4000, and your head gets 4000 here. So you created a list now. Okay, this is a create list. Let's now define the display function for this. How the display will be there, you know, it is a linked list. You have a linked list like this, then you will be starting with the very first node. So the very first node's address is in head, so this is a head, so head is having say some address 1000, so the address of the very first node 1000, 2000, 3000, 4000, this is null. So here it is 4000, 3000, 2000. Now you start with the head, so void, it is a function of class list, so display, since head is your data member, if you modify head you will lose the start address, so collect it in some temporary variable node star t. So in t you copied head now, so your head is t is your start address, so you need to display the list, you need to traverse, this is what we call traversing. So you have started from the first node, how long you have to continue, till your link becomes null. Once the link becomes null you have to stop. So what you say now, while t not equal to null, you will say, and you will display the data item, say cout t arrow data, and then you will move further again, you will go to the next node. So the next node is available in the link, t link, so this is how you make it. Say now let's start, say here t is 1000 initially, 1000 not equal to null, you get into that t data, that is say 5, 8, 9, 1, we have like this, so 5 will be displayed. Then what is t link? T link is 2000, so now t will be modified to 2000, so 2000 not equal to null, get into that, then again display the data 8, t link 3000, its data will be displayed, then again 4000, T will be 4000, 4000 not equal to 1. 4000's link is null now. So now T has become null. Null not equal to null. You will come out of that. This way you will display the list. So this is how we complete the function here now. This is what class list. We defined create, display, and list is a constructor, and then we have called main. When we have called main, create function will create the list and lst will display the list. So this is what I wanted to discuss. It was my agenda. Create a list by adding a node at the front and display the list. In the next session, what I'll do, create a list by appending, and we'll discuss display. So this way we'll continue the various operations. This series will continue. So I hope you enjoyed the session. You got the various intricacies of linked list. Hope you enjoyed the session, and if you like it, please do share with your friends. Thank you so much for watching.